Namaste and a very good afternoon to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a very interesting test which is called as independent samples t-test. Even before I proceed to go ahead and demonstrate what exactly is independent samples t-test, may I request you to subscribe to my channel, also like and share my videos. As part of the background, I'd like to begin by asking a simple question. What exactly do we mean by independent samples t-test? The answer for this question is independent samples t-test is a statistical procedure that compares the means of two independent groups in order to determine whether there is a statistical evidence that the population means are significantly different or not. I repeat, independent samples t-test is a statistical procedure that is used to compare the means of two independent groups and no more than two independent groups. This is used in order to determine whether there is a statistical evidence that the population means between the two groups are significantly different or not. There are many different names that is used to refer to the independent samples t-test. Independent samples t-test is also called as independent measures t-test. It's also called as independent two samples t-test or two samples t-test. Some people also call this as students t-test or two samples t-test. It is also sometimes referred to as uncorrelated score t-test. I repeat, uncorrelated score t-test or unpaired t-test or unrelated t-test. All these are different names that people popularly use to refer to independent samples t-test. Nextly, we'll try to understand what are the different uses of independent samples t-test. There are three major uses of independent samples t-test. Firstly, it is used to test the statistical difference between the means of two groups. Secondly, it is used to test the statistical difference between the means of two interventions. And thirdly, it is used to test the statistical difference between the means of two change scores. Lastly, now let's look at the limitations of independent samples t-test. One of the major limitations of independent samples t-test is that it can compare only two groups and not more than two groups. In case your data has more than two groups, we use a test which is called as ANOVA or simply analysis of variance. Next, I move on to what are the data requirements for performing the independent samples t-test. There are 5 important requirements that you need to look at when you perform independent samples t-test. First, that the dependent variable be continuous. The dependent variable can either be interval or ratio. Second, the independent variable must be categorical with only two categories. Third, the subjects in one group cannot be part of subjects in the second group. Fourth, the dependent variable must be normal. However, the independent samples t-test is fairly robust to the violation of normality. Fifth, we make the assumption of homogeneity of variances between the two groups, and the popular test that is used to check for homogeneity of variance is the Levin's test. With this theoretical background, let me now introduce you to the data set that I'll be working on. I've got two simple columns here. The first column is male salary and the second column is female salary. We'll be comparing whether the average salary for males and females is the same or is it different. What is the sample size in this data set? If I select all the cells, you can see here the sample size is 216. Now, let me look at the number of females working in this organization. The number of women employees working in this organization would be again 216. Now, this is a very important observation for two reasons. Because we have 216 observations for both the groups, this kind of a test, this kind of a data is called as balanced design. If you have unequal number of members in the two groups, it is called as unbalanced design. Now, a very important point here is that a balanced design is very important. In fact, it is ideal to have a balanced design when we're using independent samples t-test. A formal definition of balanced design is that we have the same number of subjects in each group, which is ideal. Now, what happens if this criteria is violated? In case we have an extremely unbalanced design, it results in the violation of the assumptions, which further threatens the validity of the independent samples t-test. The second important point here is that each group, researchers say that each group should have at least 6 subjects. This is only a thumb rule. Each of the groups should have at least 6 subjects. So if each group has fewer than 6 subjects, usually independent samples t-test does not produce good results. With this background, let me now proceed to go to StatCraft. As you can see here, this is the interface of StatCraft. It is called as StatCraft P because at the backend, we are running Python codes to execute the independent samples t-test. The dataset is pretty simple. As a first step, what I'd like to do is I'd like to display the descriptive statistics for the two groups, namely females and male employees. Let me click on the Analysis tab. Look at the second option from the top, namely Descriptives. I'll be clicking on the drop-down menu. In this section, the very first item is Descriptives. I'll click on the Descriptives option. Now, in the left side, you can see the names of the two variables, female salary and male salary. I'll click on the Options tab. Here, I have 15 different options for descriptive statistics. I'll click on mean and standard deviation. What this does is it gives me the mean salary as well as the standard deviation for the two variables. If we go back to data, we have made the selection of these two groups. Now I'm going to hit the OK button. It takes a couple of seconds for StatCraft to process this analysis. You can see here, this is the output of StatCraft. The output is displayed in the output window. You can see StatCraft displays the Python code that it is using to run the independent samples t-test. This is very useful because there is no other software, at least not that I know of, which gives you the backend code. You can simply copy this particular code and paste it in Jupyter Notebook and run the same analysis for a different month or a different region. Let me scroll down now. This is the descriptives table. There are 3 columns that you see: variable column, mean column, and standard deviation. When you look at the variable column, you have the male salary and the female salary. The second column is the mean value for the male salary. Clearly, you can see here the average salary for males is $41,279. Compare this with the second number, which represents the average salary for that of females. This number is $26,016. So roughly, there's a gap of $15,000 between the male salary and the female salary. The males being paid higher. Question is whether this is statistically significant or not. We have to check whether this mean difference is significant from the point of view of statistics or not, which we will be doing in the next step. Let me draw your attention to standard deviation. This is the third column. Look at the standard deviation for the males. It is 19,559. On the other hand, when you look at the standard deviation for the females, it is 7,572. The standard deviation for the male salary is approximately 3 times as compared to that of as compared to that of males. So for the females, we have 3 times, sorry, my apologies. For the males, we have 3 times higher standard deviation as compared to that of females. So these are important observations. One is that there is a mean difference, and it looks like it is a big difference. Secondly, the standard deviation for the males is higher as compared to that of females. With this background, let's now proceed to execute the independent samples t-test. To perform the independent samples t-test, I'll click on the Analysis tab. The third option here is Compare Groups. In this section, I've got different options. The first option here is t-test. You can see here, there are 3 different types of t-test: one sample t-test, paired samples t-test, and finally, I have the independent samples t-test. I'll click on the third option, independent samples t-test. Initially, you'll be seeing the dialog box in this form. It is asking me to specify variable 1 and variable 2. The variable 1 I can choose as the male salary. Let me again select this. Let me go ahead and do this. Right. So the variable 1 I'm choosing as the female salary, and under the variable 2 I'm choosing as male salary. As you can see here, there are 2 different options that we have. One is equal variances, and the second one is, if we specify the option as false, we will get the output for unequal variances. I'm going to first show you how to perform the independent samples t-test assuming equal variances. Assuming equal variances, and therefore I'm maintaining this as true. I'll now go ahead and hit the OK button. It looks like the output is ready. Again, StatCraft gives us the Python code that it is executing at the backend. Let me scroll down. So this is the output of independent samples t-test. You can take a look at the Python code that is used at the backend to run this particular analysis. In the independent samples t-test, what we observe is that StatCraft displays 2 values. One is the t statistic value of minus 10.67. The second is the p value, which is 9.96 into e power minus 24. When we say 9.96 into e power minus 24, it's a very, very tiny number. It is almost equal to 0. So since the p value can be approximately taken as 0 in this case, the next stage would be to compare the p value with the level of significance. The level of significance that I'm going to use here is 0.05. There is simple decision criteria. If the p is lower than the level of significance, we reject the null hypothesis. On the other hand, if the p value is bigger than the level of significance, we fail to reject the null hypothesis. There's a simple decision criteria that we can follow. Since the p value of 0.000 is less than 0.05, we go ahead and reject our null hypothesis and conclude that there is a significant difference in the mean salary of males as compared to that of females. So this is one of the conclusions that we can draw when we perform the independent samples t-test. Now, just out of curiosity, I'd like to do independent samples t-test by assuming unequal variances. Now, to do this, again, let me click on the Analysis tab. I'll now click on Compare Groups. You have different options here. The very first option is t-test. Here, I'm going to choose independent samples t-test. Now, I'm going to leave the rest of the selections as it is. Under the equal variances option, I'm going to change this to false. So here, StatCraft would run the independent samples t-test by assuming unequal variances. Let me hit the OK button. Let me scroll down. Now, this is what you're getting. The t statistic value is minus 10.67. Look at the p-value. The p-value has changed. It is 1.72 into e power minus 22, which is again a very, very tiny number. Since the p-value is very less, it is lesser than 0.05, I can reject my null hypothesis and conclude that there is a significant difference in the mean salary for males as compared to that of females, even when we assume unequal variances. You can go ahead and use the same code in Python if you want. You have to just specify the additional argument here, equal variances equals false. So this is the additional argument that you can use if you want to replicate the analysis in Jupyter Notebook. With this, I have come to the end of today's video. In today's video, we've seen what exactly do we mean by independent samples t-test. We've seen the different names of independent samples t-test. We've seen what are the uses of independent samples t-test. Further, we went on to discuss one of the most important limitations of independent samples t-test. It can handle only 2 groups and not more than 2 groups. Next, we have seen the data requirements when we perform the independent samples t-test. Remember, homogeneity of variance assumption is an important criteria. Dependent variable being normally distributed is a condition which can be ignored. Lastly, we have seen some of the thumb rules that researchers use. That is, each group should have at least 6 subjects when we perform independent samples t-test. Independent samples t-test gives better results when we have a balanced design. Not that we cannot use independent samples t-test when we have an unbalanced design, but it is preferable that we have a balanced design. Simply because when we have a balanced design, what happens is we get robust and reliable results. Extremely unbalanced results result in violation of the assumptions, which further threaten the validity of the output of independent samples t-test. With this, I have come to the end of today's video. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this particular video. Have a great day ahead.